Today we shall be looking at a problem on exponential equation. So here's the problem. 2 to the x power plus 2 to the 3x power equals 10. We have to solve this problem, this equation, for x, an element of a real number. That means the value of x that must be obtained here must be a real number, not a complex number. Alright, so let us solve the problem. 2 to the power of x plus 2 to the power to 3x equals 10 for x, an element of a real number. How do we solve this problem? Alright, we need to recall something here. You need to recall that from the law of indices, if we have, say, b to the power of mn, this is usually equal to b to the power of m to the power of n. Alright, so you will agree with me that based on this law, this 2 raised to power 3x can be written as 2 raised to power x, then to the power of 3 equals 10. Alright, the best way to solve this problem is to substitute for 2 raised to power x. That is, I can say let p equals 2 to the power of x, so that this equation becomes p plus p cubed equals 10. And if I try to rewrite this equation, I'm going to have p to power 3 plus p minus 10 equals 0. Alright, if you look at this equation, it is a cubic equation, okay, a cubic equation. How do we now get the value of p? We need to factorize. That's the first thing to do here. We factorize this equation so that the problem will be easily solved. Alright, so let us factorize. We factorize the left hand side. Now, I need you to note something. Let us assume, that this equation is a quadratic equation. Let's say p squared plus p minus 10 equals 0. If we are to factorize a quadratic equation, for example, you can multiply these two together, the first term by the last term, okay, or the third term, so that you have minus 10 p squared, and then you look for two numbers, okay, such that when you multiply them together, you get minus 10, and when you add them together, you get a plus 1 here. But you need to take note of something. This equation is not a quadratic equation. It is an equation to a power of 3. The best way to factorize this problem is to write this p. You manipulate this equation such that this p will be written in a new form. Watch. I can write this equation as p cubed, okay, minus 4p plus 5p minus 10 equals 0. Okay, so if I do this, watch, minus 4p plus 5p equals p. And when do I go for 5p? I went for 5p because I know that 10 and 5 are divisible. Okay, 10 is divisible by 5. So we have 4 terms here now. So we can group them in twos this way. Then let us factorize this guy out. P is common here, so if we bring out p, we'll be left with p squared minus 4 plus, if you factorize 5p and 10, we can bring out 5 because 5 is common, meaning that 5 can divide 5p and 5 can also divide 10. So if 5 divides 5p, we are left with p. If 5 divides 10, we are left with 2. This is equal to 0. Now you need to take note of something. This p squared minus 4, we can rewrite as p squared minus 2 squared plus 5 p minus 2. This is equal to 0. Now if you look at what you have in this bracket, p squared minus 2 squared, this is similar to a squared minus b squared, which is expressed as a plus b, a minus b. this is referred to as difference of two squares. Difference of two squares. So if you have difference of two squares like this, it means this a square minus b square can be expressed as a plus b, a minus b. That's it. So we're going to use this principle now, this law, this fact to, we're going to use it for this guy here, okay? So it means that I can have this as p plus 2, p minus 2, okay, plus 5, p minus 2 equals 0. Now, when you look at this left hand side, you will discover that p minus 2 is common here. So we can factorize out p minus 2. When we do that, we'll have p minus 2, okay? When you factorize out p minus 2 from here, you'll be left with p and then p plus 2. You will see that if you use this p minus 2 to multiply this guy, you're still going to have this guy, okay? So this is just 5 because you have factorized out p minus 2. So this is p minus 2 now. If we clear this bracket, we're going to have p squared plus 2p plus 5 equal 0. Alright. Now, you need to take note of something. Let us recall. If AB equals 0, okay? If A multiplied by B equals 0, then it means that either A equals 0 or B equals 0. At least one of these two numbers or one of these two letters must be equal to 0. So it's either A equals 0 or B equals 0. So we're going to use this fact for this. So it's either p minus 2 equals 0 or p squared plus 2p plus 5 equals 0. Alright, so that said, let us continue. So from here, we see that, so this is either p equals, so if you collect terms, if you take this minus 2 to the other side, or if you add 2 to both sides, you are going to have p to be equal to 2, or p squared plus 2p plus 5 equals 0. Now, take note of something here. From the equation given to us, we were told that the value of x must be a real number. The value of x must be a real number. Now, if p equals 2, 2 is a real number. But if we are to get the value of p from this quadratic equation, the value of p here will not be a real number. Let us check it out. Let's try to solve this guy. So a is 1, b is 2, and c is 5. So if we put this into the discriminant, okay, of a quadratic equation, don't forget that a quadratic equation is given by minus b plus or minus root b squared minus 4ac over 2a. Alright. The solution to this problem, or should I say the nature of the roots of this equation, is determined, okay, by this discriminant. This b squared minus 4ac is called the discriminant. So if we try to get the value of this discriminant, b is a 2, so this is 2 squared minus 4 times 1 times 5. You will see that this is 4 minus 20 and this is negative 16. It shows that the discriminant is a negative 16, which is not a real number. So that means the nature of roots of this quadratic equation is not real. So that does not satisfy the condition given to us in the problem, because the problem says that the value of x must be a real number. So it means we have nothing to do with this equation, since this equation will not provide a real value of p. So we are going with only p equals 2 as our only value. Alright, but we can't stop here, because the equation says we should find the value of x, not the value of p. We introduced p so as to ease our calculation. So we will recall that p equals 2 to the power of x. Now that p equals 2, it means that 2 equals 2 to the power of x. So if we rewrite this 2 in index form, that is 2 raised to the power 1 equals 2 to the power of x. And from the law of indices, if you have an index here and an index here, separated with an equal sign, and it is such that the bases are the same, then it means the powers are also going to be equal. So it means that the value of x here is 1. And as always, we are done. So the value of x here is 1. Alright, we may try to go into the equation as a check to see whether we are right or wrong. The equation says this equals 10. So if we put 1 here, this is 2 to the power of 1. And if you have 1 here, that is 3 times 1, that becomes 2 to the power of 3. 2 to the power of 1 is 2. 2 to the power of 3 is 8. And 2 plus 8 is 10. Alright, viewers, this is all I have for us today. Our value of x, for which 2 to the power of x plus 2 to the power of 3x equals 10 is x equals 1. Alright, so this is how far we'll go today. This is all I have for us today. You can ask your comment, question, and contribution in the comment section below.